Welcome to myprojectbazaar.com. Title of our product is Wide Range Adaptive RF to DC Power Converter for Ultra High Frequency Radio Frequency Identifications. Now we are going to discuss about the abstract of our product. A wide range differential cross-coupled rectifier is proposed with an extended dynamic range of input RF power that enables wireless powering from varying distances. The proposed architecture migrates the reverse leakage problem in conventional cross-coupled rectifier without degrading sensitivity. A prototype is designed for ultra-high frequency radio frequency identification applications and is implemented using 0.18 μm CMOS technology. On-chip measurements demonstrate a sensitivity of -18 dpm for 1 volt output over a 100 kΩ load and a peak RF to DC power conversion efficiency of 65%. A conventional fully cross-coupled rectifier is fabricated comparison and the proposed rectifier shows more than 2x increases in dynamic range and 25% boosting in output voltage than the conventional rectifier. In this process, the radio frequency is an input and the DC voltage is an output corresponding to the sensing signal with high voltage. Now we are going to discuss about the flow diagram of our product. Our product can be implemented by using a complementary metal oxide semiconductor technology circuits. The combination of PMOS and NMOS is called as an CMOS, that means complementary metal oxide semiconductor, and some noise reduction blocks and the feedback elements. First, the radio frequency signal is directly applied into the noise reduction block. Two different radio signals are applied. They are positive radio frequency signal and another one is a negative radio frequency signal. These positive and negative radio frequency signals are fully affected by noise. In order to reduce this noise that can be applied into the noise reduction block, this noise reduction block contains some capacitors. After reducing the noise, they can be applied into the CMOS technology circuits. These CMOS technology circuits contain some PMOS and NMOS designs. This CMOS technology circuits output can be directly applied into the noise reduction block. This can be another one time to remove all the noise in the frequency signal. They can be directly applied into the feedback network. In this feedback element contain a different 4 NMOS device to control the conduction of the rectifying devices, and self DC biasing is dynamically applied into the PMOS gates only in the presence of high input power. The output of the feedback network is directly applied into the some feedback transistors by a dynamic approaches. They produce a final output DC waveform signal. Now we are going to discuss about the running procedure of our product. Our product can be implemented by using a Tanner EDA tool 13.0 version. Click to open the tool window to create a new design from a file option. Now we are put the design name in desired path. After creating the file, add the library files from add option. Add the Tanner all libraries using this option for a desired path. After selecting the Tanner all file, click OK. After adding the library files, now we are going to design our module using cell option to create a new view. This cell 0 can be editable. We can change into our desired name. In our product, two modules can be implemented. They are adaptive rectifier and single stage cross coupled rectifier. First we are going to select adaptive rectifier to start simulate. This is an output waveform of an adaptive filter rectifier. This waveform can be expanded by expand chart option. This is an input of radio frequency, positive input of radio frequency VRF plus. This is a negative input of radio frequency. Both are independently aligned. They can be produce the final output of DC power VD0. This is an output of a DC power. RF plus and RF minus both are the input radio frequency, and then D0 is an output DC power. Now we are going to select a next module to start simulation. Last and final module is a single stage cross coupled rectifier. Select a single stage cross coupled rectifier. Start simulation. This is a final output waveform of a single stage cross coupled rectifier. Expand this output waveform using expand chart option. VRF plus is a positive radio frequency. It is a negative radio frequency. Both are combined and then they are applied into the feedback element. They will produce the final DC output power. VDC is a final output waveform of single stage cross coupled rectifier. Thank you for watching this video.